Hello there. In this video, I'm going to go over some of the materials that you had for today in your readings and kind of pick out what I think is important, make a few extra points here and there. But this is drawing heavily on the reading, which was the Think CS Runestone website reading, Chapter 1, General Introduction. There are some things in there that are less important and some things that are more important, but it's a good general introduction to some important ideas around programming. So if you haven't seen these things before, it might be very useful for you. Let's take a look at my class notes for today. I'm going to try to make them a little bigger if I can. There we go. There's more to these class notes that we'll use actually live in class. These are the only part that I'm actually going to go through in this video. I talked about Python and PyCharm in an earlier video. So we're going to start here with algorithms, which is a section. It's a very, very short section in your readings. And there's more here that I think is really important. So the idea of an algorithm is what I want to talk about. We use this term a lot in computer science. It has a special meaning. It's a different meaning from when we use the term program, although they are related. And there's actually, in fact, a whole course called algorithms later on in the computer science curriculum. So what is an algorithm? What I've got here first is basically a definition. My definition. There are lots of variations on this. An algorithm is a structured set of instructions that describe how to perform some task. So there are algorithms in many different fields of study. They may not call them that, but they exist. And mathematicians have been talking about algorithms for a very, very long time. In fact, the word algorithm is a mutation of the name of a Muslim scholar who wrote down a bunch of different methods for calculating things in many, many years ago. So what's important here is that algorithms describe a process, steps for performing something, for calculating something, for doing something. And process is at the heart of what computer science is all about. We are not so much concerned with just getting the correct final answer. We want to be sure we understand the process and we examine the process that's used to come up with that answer, to see if it's the best possible process, if it's efficient enough, if it works in all cases, all of those kinds of things. So algorithms are a key concept for computer science. I have here some examples of algorithms, and I'm actually just going to show you some. They're not all in the order that I put them here in my notes, but there are lots of examples of algorithms that you run across in your everyday life. So here's one. This is a recipe. This looks so tasty. A recipe is an algorithm. It's a set of instructions that's highly structured generally that tells you how to make some food. So the structure is particular to the fact that it's a recipe. We usually have a set of ingredients that are described and measured, and then we have a sequence of steps that are one by one need to be performed in that order until you get to the end and the food is prepared. So this is a process. This is a kind of algorithm that's specifically for the purposes of doing cooking. Others that I list here, assembly instructions. I went and found online assembly instructions for part of an IKEA desk, because IKEA instructions are notorious for their lack of words. They want them to be usable by people regardless of what language those people speak. So they use pictograms entirely instead of text. But still, this is a structured document. It's going to give you pictures that suggest how you might want to go about it. And then it has lists of items that are part of this. And then it has step-by-step pictures that describe how to perform the task. You can quibble about whether those pictures are a great description or not, but actually they're really good. If you've ever put together furniture made by other companies, you'll know that IKEA instructions are way better than the average. Giving someone directions for how to get somewhere is a good example. Here I have, I'm going to actually try to zoom this in if I can. Here I have instructions from Google Maps on how to go from the Olin Rice Science Center to our local Trader Joe's using public transportation. So again, it's structured. You might have a map when you have driving directions. You will have step-by-step instructions. In this case, they're specific to time because they're talking about right now, if you wanted to do this task, what were the times you would actually have to be various places, and how long would it take? It's another great example of an algorithm. Mathematical calculations I mentioned before. You learned lots of algorithms when you were in elementary school, primary school, because that's what you do first when you study mathematics, is you learn how to add numbers together, how to subtract numbers, how to do multiplication. For each of those, you learned one or possibly more algorithms for doing those calculations. They may not have been described to you in that way, but they really are. They are algorithms. And then, of course, we have programs. Now, programs are another example. I also want to include that there are different ways that we can describe a program that we want, something we want a computer to compute, to perform. So one way is something we call pseudocode. And pseudocode is going to be important for us. We're going to we're going to ask you to write pseudocode and also to read pseudocode that we provide for you. So what is this thing called pseudocode? It is not a program because it's not something that a computer can understand. It's written for people to understand. In this case, I found a YouTube video that happened to have a particularly nice, clear view of pseudocode for a particular task. The task here is not so important. What I want you to see is that there's structure here. We've got indentation. This is actually following certain programming languages kind of closely in the use of the curly brackets and some of the other terms. But generally, this is written with English in it. It says initialize, index equals 0. While index is less than the number of items in the list. Number of items in the list is English. So when we write in pseudocode, we usually have a sequence of steps. We might have an overall header or label. We might have things like special words like while and if and return that mean something similar in many different programming languages. But we're also allowed to just write out steps in English where we want to. We're going to talk a lot more about pseudocode, but keep it in your mind. This is an important way to describe algorithms before you actually, or instead of actually turning them into code in a programming language. I have other examples. Here is another description of the linear search process, but in this case it's done with a flowchart. So it's a diagram view. I'm going to make it even a little bigger than it is. It has a starting point. This is a decision point, so you ask a question and you change where you go depending on the answer. Are there more items? Yes, then go down here. No, then you go down here to the end. And you can see that it's got a loop structure here, so it's doing this part over and over. In the pseudocode, that loop structure would be handled by this while statement. This indicates that we're going to repeat something over and over. The if statement is more of a decision point. Do we want to continue or do we want to stop? And that is shown with these other kind of boxes here. So we can draw a diagram, and that's a perfectly good description of an algorithm. We can also write an algorithm in code. So I have the same algorithm, linear search, written here in Python. Now, if you look at this, as someone who doesn't know Python yet, most likely, maybe some of you do, but most of you don't, this may be harder to read than, say, the pseudocode or the diagram, where those are aimed at people. They're meant for humans to read. When we have to write a program, there's always this conflict between what the computer can understand and how people want to describe things. And a programming language is is stuck at that intersection. We have to adjust ourselves to what the computer can understand, and we try to make the programming languages better by extending what the computer can understand to be closer to what humans want to do. But a program is a perfectly good version of an algorithm. Now, when we're going to be working over the course of this course, we will ask you to write pseudocode sometimes, because it's sometimes good to get away from the details of the programming language and focus on what you want to accomplish, and make sure that is clear in your head before you actually start to try to make actual code. All right, so this has gone over this concept of an algorithm. I think I'm going to stop here, and we'll pick up with the other aspects of this first set of materials later in another video, because I had a lot more to say about the algorithm section than your reading did, and I don't want that to get lost. So I will see you in the next video.